Okay, this is video number 2. Okay, when you measure temperature, you're going to use a physical quantity. And this physical quantity must change with temperature. So for example, you could have length changing, in other words expansion. You could have resistance. You could have voltage, or once we've done electricity, I prefer you to write EMF. And a few other types. You could have volume, you could have use a bimetallic strip to, and you've got a curvature, so you've got an angle. So there's many different things. Now, when you think of measuring temperature, you usually think of a thermometer. So the most common one is a glass bulb, or liquid in glass bulb. Now this effectively the first step you do is you create a scale. Okay, degrees Celsius, we have 2 fixed points. We have melting and boiling. So melting is at 0 degrees Celsius, boiling is at 100 degrees Celsius. Now if you put this thermometer into a bath of ice or something like that, and you melted it, then you could find where the solution ended up for 0 degrees and for 100 degrees. Let's say this was 20 centimeters, this was 4 centimeters. Then in between that you're going to put in 100 divisions. So to find out the size for each division, you find the rise, which is going to be in this case 16 centimeters, and divided by how many divisions, and it tells you how many centimeters per 1 degree C. Now the other thing to think about is how the size of the bulb can change the thermometer, how the size of the capillary tube can change the thermometer, how the actual liquid in the bowl can change the thermometer, and also the thickness of the bulb. And things that you've got to think about here is range, how far it goes up and down, the sensitivity, which is effectively how much it changes per degree. Okay, what's the rise per degree? How sensitive is it to a change in temperature? The other thing is linearity. Okay, so a key thing for range, let's say you had a bigger bulb. Well, bulbs that are bigger has a greater step per degree. So if we've got the same height tubes, then this one is going to go up this far for 1 degree. This one might only go that far. So this one has less range. However, you could say this one is more sensitive in terms of the size of the increase per degree. It is much more precise. Other problems though, this one is longer to heat. Okay, it's much bigger, so it'll be longer to heat. And the other things you can think about is, well, if you use mercury, it has a much higher boiling point than ethanol, so you can use it for a hotter temperature, and so on. Now what's a thermocouple? A thermocouple is one type of metal attached to another type of metal in two junctions. So let's say this was iron, this one was copper. You would actually get an EMF at the junction between the two metals, generally because you could think of like a chemical reaction being there. Now if you actually measure this thing with a voltmeter, you can get a specific voltage for a certain temperature. So you could go from, let's say, 0 degrees to 1,000 degrees, and you might go from something like 0.01 volts to 1 volt. So the voltage changes as you change temperature. Now the reason we have two junctions is one of them is usually at a fixed temperature of 0 degrees Celsius. Now the key thing here is usually it's not a linear change, so if we actually had the voltage versus temperature, it would not be a straight line, it would be a curve. So using this graph you could actually find out for a certain voltage what the temperature is. The main use of thermocouples is that they can go to high temps, they are small, and because they're small they're quick to change.